Well, I'm really excited. My name is Chad Close. I'm really excited to be here today with the Nodes community and Neo4j to talk about how Intuit's security team uses Neo4j to drive down MTTR and MTTD. I'm part of the platform security and compliance team here at Intuit. But first, I want to start with some definitions, just rough definitions about what MTTR and MTTD are. So MTTR is the mean time to resolve or remediate, and MTTD is the mean time to detect. And for context, this is going to be about security-related incidents, vulnerabilities in libraries, vulnerabilities on endpoints. In general, it's going to be security context-related. So stepping back to the problem statements, how do you manage and or remediate resources and infrastructure that you can't see, or you don't understand them because it's legacy, or you're new to the project and you have a hard time visualizing it. So, and then how do you increase that speed and reduce that complexity of managing these resources that you may not know about? It really is a problem that we faced, and our specific use case was when we were, my colleague and I, Zach, we were on a project, and we were given a P0 security incident. In this incident, we had to trace where the front end URL was being mapped in through Akamai, through the various levels of DNS delegation, from our central DNS to AWS Route 53, and and then the multiple layers of abstraction and of our internal reverse proxies and the infrastructure that made up this particular endpoint. And it was a very complex manual effort of going through and logging into the various applications and drawing out that information and then manually mapping it out. And we knew we could do it better. It took lots of tribal knowledge and special access, and it just was really cumbersome. And so we ventured to into we have these global engineering days where we can work on things that we want, and we were able to build a system that allowed us to automatically ingest this data from the various disparate systems, and then using nodes and relationships and Neo4j specifically, we were able to automatically give insight about how the infrastructure is laid out. And then also we were able to map vulnerabilities exposed externally. The graph on the right is, hey, this particular library is found in these GitHub repos, and it has a CVE. And we can then see from there, expand this GitHub repo, where are these endpoints or where is this code exposed out on the internet, so that we know and can target the most critical things to go and fix first. And we also married that to the teams and the GitHub committers, and so we could rapidly deploy those teams to go and address any of the issues associated with it. We were successful in taking this data and taking these manual hours of investigation and mapping, and we were able to ingest the data into Neo4j, and we built an API that sits in front of it. And if you had the chance to go to Zach's earlier talk, he talked about the NodeStream library that makes it declarative and also gives you the ability to expose it via a GraphQL API. And it allowed us to go from these, sometimes it wasn't even possible, vulnerabilities to endpoints, or it was manual or took hours or days. And now we can do it within seconds because we have an API that you can call and you can get the data back. And it gives us these strong inferences of related data. So where are we going from there? Well, as everybody's aware, Log4j happened, and the power of the graph in Neo4j and the data collection and the knowledge graphs that we were able to build as a result of these ingests, it allowed us to start tackling supply chain security and the software bill of materials. And just again, another definition is what's software bill of materials. Software bill of materials is like the ingredients of a recipe, the ingredients that make up something. In food, you want to know if it's got, if you have an allergy, you want to know if it's got milk or dairy or peanuts or nuts of some sort. Software is the same type of thing. In the case of Log4j, you want to know if your software is importing these vulnerable libraries so that you can go and rev them, or you can remove them if they're not necessarily being used too. So on the left, you can see that, oh, we have an allergy to peanuts. We need to know which foods that we have that have actual peanuts in it. Same thing for Log4j. We need to be able to know that this vulnerability exists, and it exists in our application stack. Our long-term vision around software bill of materials is to give us an improved supply chain incident response. So we know that we have vulnerabilities in software, and we know we need to remediate them, but we need to prioritize them from low to high. And so we want to improve that by identifying where these things are currently in our infrastructure, in our applications. And then we also want to have a comprehensive SBOM management. That SBOM management is critical so that we can target and or influence people away from certain libraries, or just be able to manage them. Currently, we're looking at Cyclone DX as the mechanism by which we're going to define our SBOM. It allows us to do risk management so that we can prioritize again from high to low, and where we can also add on the layer of, is this exposed externally, then it increases the riskiness associated with it. Whereas if it's a high risk vulnerability but isn't exposed anywhere, then it could be less of a priority. So this risk management is important. And one of the things that Intuit is striving to do is specifically the security team under Eric Lee and Gabe Gallagher's, we're striving to be a leader in this SBOM space. This is one of the reasons why we're here to talk and share our journey. We want to, we've open sourced our ingest method, and I will refer you back to, I'm going to talk about the ingest method a little bit later, but I'm going to refer you back to Zach's deep dive earlier in the day. So if you missed it, go check that out. And we want the industry to learn from our experience and from what we've done over the last couple of years to really enhance our visibility and to drive down or increase our ability to do MTTR and MTTD. Well, so how does SBOM attribution improve a zero-day incident response? Well, if you don't know where the libraries are and you don't know where they're deployed, then you end up struggling to prioritize what needs to be remediated. So as part of our journey, we can say these repositories have these libraries and have these vulnerabilities from our code scanning tools. We can then compile an SBOM that potentially has something that we want to keep track of, and then we track it via deployment mechanisms all the way into the infrastructure and where it's currently running in an AWS account or a Google Cloud account, or through its deployment where it's actually being seen in the runtime. So some of the challenges that we've run into in doing this is scale. We're talking about thousands and thousands of repositories and millions and millions of lines of code, and it really gets complex scaling up. Neo4j has done a great job. I'll talk a little bit about the numbers a little bit later, but scaling has been a challenge, scaling up to being able to collect all this data, having disparate systems of siloed data. This is where Neo4j and nodes and relationships in the graph database it shines, is taking these disparate data sets and linking them together. And then also, tribal knowledge, being able to find the people that have the information and be able to extract it and then codify it. Those have always been a challenge, finding it and then being able to codify it. Temporal dynamics, we have ephemeral instances that'll spin up and spin down. So finding those things, those have been a challenge as well. But through these inferences and taking this data and linking it together and creating these knowledge graphs using the graph database has really increased our ability, our speed and our accuracy around what is important to tackle and where it is. And, it gives us that visibility. It gives us the ability to do the hygiene and to react as quickly as we need to in this relationship-centric model. And it gives us a powerful querying engine that we can then use for lots of different things. I'm going to talk real briefly. Zach gave an excellent talk earlier, a deep dive on the declarative ingest. But before I talk about the declarative ingest, I just want to share some of the numbers of what we're dealing with. 20 million events per hour, 75 million database updates per hour, over 50 data sources. And right now we're at 254 million nodes and relationships. And we get signal from all over the enterprise. We have created our own extractors, which collect data from things like AWS and Jenkins and GitHub and Snyk and Akamai, and we have ingested this data and linked it together in such a way that it gives us powerful insights and the ability to infer. One of the things that we ran into is all of the disparate data sets have data that come in different ways. And so it created a challenge, but as a result, we defined an open source library that we've released called NodeStream. And this NodeStream library gives you the ability to declare in a YAML format, similar to like CloudFormation, if you're familiar with that, what resources and what data that you want to map to nodes and relationships. And it does lots of cool things, like auto creating indices and constraints. And then it gives it a simple interface that allows you to go from a slow custom code ingest method of ETL type stuff that's error prone, and you have different engineers doing things differently, to a declarative model with reusable code that's hyper optimized for database writes, where it coalesces and combines things before it sends it to the database. And it gives an environment where it's easy to onboard an engineer and gives a centralized place to write some of these, what we call pipelines. And these pipelines take this data, it normalizes it, and then sends it to the database. And one of the key aspects of the library is it automatically attributes where the data is coming from, so that when the node or relationship is written to the database, you know exactly where that data came from a pipeline ingest perspective. And that's crucial for us because we need to be able to backtrace and have that chain of custody so that we can, prove or disprove where this information is coming from, because it's a security related incident. One of the accidental side benefits of this declarative nature of the ingest is now we can generate the GraphQL schema from this declarative pipeline so that you can just automatically ingest it into a GraphQL API using something, for instance, Apollo. And this declarative nature allows this to spin up this API within minutes. It really is one of the best advances in the library. And overall, so we have had huge success that's been celebrated internally, and now as we move into the open source and sharing with user groups, success externally, and we're attracting other companies, and it's been really a fun journey. We've driven down our MTTD and our MTTR numbers consistently for the past 4 quarters by increasing our ability to expose this via API, and it really is a great tool that we're proud of, and we want to share and share our journey. Pro tip: coarse grain attribution and detection first, then you refine as you go. It's not boiling the ocean. We hear that all the time, but it is achievable. And just start simple and allow it to evolve and grow. It's one of the things that we've had success in. I do want to give a shout out to our mascot George and our awesome team of engineers. We've had a tremendous amount of fun building this over the last couple of years, and our leadership team has been super supportive of Gabe and Eric, and it really has been a wonderful journey. And I'm going to open it up to any questions if there are any. Let's see.